Welcome to Denslet, a channel for intelligent and curious people like you who are searching for human sexuality and spirituality in the age of artificial intelligence. And in this channel, we usually try to find the best possible answer to a question. And today's question is how our lab robots move their limbs, how they walk, how they run, how they jump, how they ride, how they move their limbs. Spreading their legs or something, anything you can imagine of. Okay. So we are diving into the fascinating world of robotics and technology. So today we are breaking down an essential aspect of robotics that is behind every move and action, that is control signals. So let's get into it. But before we proceed, let me tell you two things. If you have not subscribed yet, please subscribe. It means a lot to me. And if you have already subscribed, tons of thanks for your support. Secondly, I have started a membership zone for a minimum price of less than 50 cents, that means half a dollar per month. You can join there and support Wooden Select. So, thing is, at the core of the robot movement, if you think of any kind of movement, there are control signals. These are digital signals made up of zeros and ones. I talked about zeros and ones, that means two binary numbers, especially very essential, relevant for any kind of robotics movements and all other things, even thinking, even artificial intelligence. And they play a crucial role in telling a robot's actuators. Actuators are actually motors that run the robots and grippers how to move and when to move. Think of control signals as the instructions a robot needs to perform specific tasks. These signals are represented digitally, which gives us precise control over the robot's actions. Here is how it works. I am trying to tell it in a way so that a layman can understand. Not that everyone is quite familiar with technology, of course not, but they are curious to know about robotics and all the things. Thing is, each control signal consists of a sequence of zeros and ones. This sequence determines what action the robot should take. For instance, a particular pattern might command a motor to rotate clockwise at a certain speed. These signals are sent to something called a motor driver. Motor drivers are electronic circuits that convert these digital signals into analog voltages or currents. This conversion is crucial because the motors need analog signals to actually move. Once a motor driver does its job, it sends the signal to the motor, which then moves in the desired direction and at the desired speed. Let's look at an example because example makes everything clear. Imagine we have a humanoid robot's arm that needs to move forward. Suppose it will grip something of you, some part of you. To do this, a series of control signals are sent out for a single movement. Remember, first a signal might be sent to the shoulder joint to rotate it forward. Then another signal goes to extend the elbow joint, and finally a signal to keep the wrist neutral. By coordinating these signals, the robot can perform complex actions like reaching out or waving. But it's not just about sending signals. Several factors affect how these signals work. The robot's desired movement, its current state, like its position and speed, and external factors like obstacles, can all influence the control signals. And as robots become more advanced, so do the techniques for controlling them. We have feedback control, which uses sensors to adjust signals based on the robot's actual movement. There is also trajectory planning, where a sequence of signals is pre programmed for complex paths. Plus, machine learning is being used to optimize control strategies based on experience. In essence, control signals are the language that allows a robot's digital brain to communicate with its physical body, enabling it to perform a wide range of movements and tasks. So, that is it for today, and I hope it makes a sense how a robot moves. Very single movement requires a typically requires a very complex process. and it does not suddenly fall from the sky. It does not happen suddenly. It requires a lot of things to be calibrated at once at one time. So that is it for today. If you like this video, please subscribe, hit the bell icon for more insightful content on artificial intelligence and robotics. Moreover, consider joining us to support Wooden Slate. Don't forget to share with your friends. So, see you in the next video. Till then, goodbye. Thanks for watching. Take care and stay safe.